He were asked to sketch the graph, and to do so, I'm going to find any asymptotes, holes in the domain and range. So for this case here, when we look at the vertical asymptotes, there's not going to be any holes because there's no value of x that makes the numerator and denominator 0. But there is a number that x can be equal to make the denominator 0, and that's at x equals -1. So that is our vertical asymptote when x is equal to -1. So I'll draw that on our graph here. Next up for our horizontal asymptote, so like we said, no holes, but horizontal asymptote, we're looking at the degree of our leading number here. So x is to the power of 1 and x is to the power of 1. So since they are the same, then our horizontal asymptote is the coefficient over the coefficient of our leading term. So in this case, it's just 1 over 1. So that means that we have a horizontal asymptote at 1. So y equals 1. We got our horizontal asymptote. Sketch that on the graph. Again, we have no holes, but domain and range here. Let's talk about the domain first. So obviously the domain cannot be anything it can't be -1. So what that means is I'm going to go ahead and use, let's say, set notation here. So x cannot be -1. So what that means is to sketch this graph, we got to know, okay, what's happening on the left side of the vertical asymptote and what's happening on the right side. So to do that, I'm just going to plug in a number. So what that means is f of x equals -2 minus 1 over -2 plus 1. See what that does. -2 minus 1 is -3. -2 plus 1 is -1. So that's at 3 there. So when we have -2, +3, that lands right here. And let's check on the other side. So I'm going to go ahead and plug in 0. So let me change colors here. F of x equals 0 minus 1 over 0 plus 1 equals -1 over 1 equals -1. So 0, -1. And so our graph here is going to look something like this. Now we know which side it is on. So there is the sketch of our graph in pink.